Welcome back. In this video, I'll be demonstrating how we can do this allocation table. So as you can see that I have three disk groups created. One is external redundancy and one normal and one high redundancy, naming with DG1, DG2 and DG3. So I have a total of three disk groups which were already created, and the disk group numbers are given as above. Okay, now let me connect to the database and create a table space. I'm trying to create a table space test DB. I'll be creating it into the DG2 disk group. DG2, which is a normal redundancy. I'm creating it with very small size of 5 MB. Now let me see the data file name. Yeah, this is a new data file which got created in disk group DG2. Let me connect back to ASM instance. So we created this data file in DG2, which is a group with the group number 3. Now let's see the data disks which belong to this group 3. So these are the two disks which belong to the disk group DG2. So now let's try to find out this allocation table from this disk. So I'll be using kfet read, and I'm selecting the disk 11. And allocation unit 0, and I said that it will be in from block 2 to block 255. So first let me see for block number 2. So block 0 is reserved for disk header, block 1 is for free space table, and from block number 2 to block number 255 are reserved for storing the allocation table. So now I'm trying to view the content from the block number 2, which is the first allocation table block of the allocation table. So I'd like to move it. So this is the block which says that it's a metadata. This block is used to store the metadata information, and this block belongs to the allocation table. And I said like AU number. Here you can see this is the first allocation unit number that is addressed by this allocation table block, and the string space and the string value 448, which means that this allocation table block has total 448 allocation units and kept at 0. So each allocation unit number is the index for this value here. So for kept at 0, that is for allocation unit 0, we can see, as I said, like we have the file number, and the extend number V indicates whether this particular allocation unit is occupied or if it is free, and the extend numbers use the extend number of this file. Now let's try to find out for our file, right? We created the file with 256. So now let's see where this 256 file exists. So we can see this file number here, which is in hexadecimal format. We can convert that into the decimal format. Let me try to put this value here. So we can see this, the decimal value of this representation is 256. So 10 into 100, which is in hexadecimal format. So our 256 file has the allocation unit 52. So 52 allocation unit is allocated for storing the file with the file number 256 and the extend number. So here we can see the extend number 0 into 6. Just convert this into the decimal value. So we have an extend 6 here, and this could be the extend 9. First, let me collect this information. I'm just taking out all the extra numbers. So 52, 53, 54, 55 blocks. Sorry, up to 54, 52, 53, 54 allocation units are allocated for the file number 256, and the extend numbers we have here are 6, 9 and 10. And similarly, two more extends here, two more allocation units, that is allocation unit 56 and the allocation unit 57 are also reserved for or also allocated for storing the file number 256. And one more allocation unit 59. So this is the allocation table from which we can see the extend number. If this particular allocation unit is assigned for any data file, is allocated for any file, then we'll have the file number, extend number and the status of this allocation unit in the allocation table entry. And as I said, like one allocation table block can address up to 448 extents. Sorry, 448 entry. It can have up to 448 entries. So here you can see the last one which is addressed is 447. From 0 to 447, which is nothing but total of 448 entries that are there in the first allocation table block of allocation unit 0. Now let's try to see the third block of the same table, allocation table. So I'm just trying to view the content from the block number 3. So here we can see the same allocation table. This block is storing the metadata for allocation table. And now here interesting thing is that we can see the AU number as 448. So I was explaining about the offset value. So it means that this allocation table block addresses the first allocation unit. Means in this allocation table block, the first allocation unit, it has the entry for 448. And from 448 to the next 448 allocation units we'll be having in this allocation table block. But the string here we can see that string value 448, which means in this allocation table block we have entries for the next 448. From 448 to the next 448 entries we'll be having in this block. And similarly, if you are looking for the next block, block number 4, Here in this block, the starting allocation unit number that is addressed in this block is 896. From 896, the next 448 blocks are addressed or will be having the entries in this allocation table block. And similarly, till 255, block number 255 are reserved for the allocation table. So let me view the block number 255. So here we can see that allocation unit, this is the starting allocation unit that will be addressed by this allocation table block. Here we can see the string value is 0. It means that whenever we have the string value as 0, this allocation table block does not have any allocation units to address. That means I have a data file. I created the disk of 3 GB size. So 1024 into 3, which is nothing but 3072 is my size of the disk. So as I said, like one allocation unit is equal to 1 MB. So in one allocation table block, we can have 448 entries, right? So in that case, 3072 divided by 448, which is nothing but will be having the value, all the allocation units in this disk were accommodated only in the first 6 blocks of allocation table. So let's say that the allocation table block starts from block number 2. So as I said, like 6.8, it means that first 7 allocation table blocks has addresses of all the allocation units on this disk. Now let me view the block number 7. So here we can see that string value is 448 and the allocation unit number, this is the allocation unit number that is addressed in this. So 7 plus 2, but that is 9. Here we can see that. So what is the size of our file? 3072. So does this address anything? It means that this block is not addressing any of the allocation units of the disk, because the size of the disk is very small, just 3 GB. So if we are having a allocation unit of size 1 MB each, then in the first 6 blocks, allocation table blocks of allocation table are sufficient to address all the allocation units on this disk. So this is where our string value shows that we don't have any allocation units information in this allocation table block. Let me try to view one block, which could be the last one here. Yeah, here we can see, right, 26, and in this block the string value is showing as 379, which means that in this block we only have 379 entries for allocation units. It means that only 379 allocation units are addressed in this allocation table block, because those are the only allocation units that are left on the disk. So as I said, like allocation table has the extra number, file number, information, right? Let me show that. So I'll run a query. So I created a file with size 256. So let me view this. So our group number is 3. So I'll correct this query by updating the value to 3. And our file number is 256. So here from this output we can see that I've created a file of size 5 MB, so which means that I have a 5 allocation units from 0 to 5. So total 6 allocation units will be created. Allocation unit 0 has some information related to the file header. So from allocation unit 1, so let's say like these are the physical extent. For this file we have total 12 physical extents got created from 0 to 11. So total 12 extents, that is nothing but 12 allocation unit. As I said, like for every file, the first 20,000 extents is equal to the size of allocation unit. So we have just 12 extents, which is less than 20,000. So the size of an allocation unit is equal to size of your extent. So as my disk group is normal redundancy, so I will be having one physical copy. I will be having one primary extent and one image copy of that extent. So for every, you can see from the virtual extent, total virtual extents are 5, and each virtual extent has 2 physical extents because of normal redundancy. One is the primary extent and the other one is the image copy of that, or we can say the mirror image. Okay, so let's consider like physical extent or the extent numbers. Now let's start with block number 2. So I'm verifying for this number 11. So I said like fnum, this is the hexadecimal value. When I converted this into a decimal value, I got the value as 256. So this allocation unit 54 has been assigned to the file 256, and the extent number is given as this is the one from allocation unit 52. From 52. These are the allocation units, first 3 allocation units that were assigned, that were allocated to the file 256. Now here we can see that on disk 1 we have an extent number 1. This is the extent number xnum equal to 06, which is nothing but the extent 6 is on disk 1, and the extent 9 is on disk 1, and the extent 10 is also on disk 1. So let's see first extent 6. From the previous output, the extent 6 is on disk 1, so 0 and 1. So 0 is the first disk, which is disk 11, and 1 is the second disk, which is disk 12. So now I was using kfed read for reading the disk 11, which is nothing but your disk 0. So the extent number, right, you can see the extent number 6, and the allocation unit number 52 is on disk 0. Extent number 52. So extent 6 and the extent number 6, file number 256 is on disk 0. And similarly we also have an extent number 9, extent number 10, extra number 5 and extra number 0, extra number 9 and 5 also on this same disk. Let's see the extra number is 9. Yes, it is there on the disk 0. With 53 is the allocation unit number. Extra number 10 is also on disk 0 with allocation unit number 54. So 53, 54 is on this extra number. So one thing we need to look at is the disk number. So as I said, like one is the primary extent and the other one is the virtual extent. But all those extents, both the primary and the other extents, we have a total of 12 physical extents. So out of this 12, 6 physical extents would be on one disk and the other 6 physical extent would be on the other disk. So clearly we are also able to see the which extent number is on which disk, and that extent number belongs to which allocation unit. So now let's find out the other disk. Now let's query for the disk 12. So here we can see the file number. If you convert this into this is the hexadecimal value. If you are converting this into decimal, we'll get the value of 256. So for this, what is the extent number? Extent number 8. So extent number 8 and the extent number 11 and the extent number extent number 8 and the extent number 11 are on the second disk. So let's verify in this previous output. Extent number 8, yeah, from the disk number 1, it means that this extent is on the other disk. Extent number 11 is also on the other disk. So we can see that even the allocation unit numbers. So with this, from the allocation table, it is clearly known that which allocation unit number. So all these indexes kept that of I is nothing but your the allocation unit number. So this allocation unit number is assigned to which file and which extent of that file. So we have every information in this allocation table blocks or the allocation table. So each allocation table block has entries for 448. So this is how we can cross verify the allocation table blocks. Now one thing that we need to remember is the string size. Here we were able to see that 448. But let's see I have a high redundancy disk group with allocation unit size of 4 MB. Previously my AU size was 1 MB and now the size of my allocation unit is 4 MB, right? So let me create a data file in this. So here this time I'm creating it in a disk group of DG3, which is a high redundancy disk group. And size I'm just giving as a 10 MB. So I must be having 10 allocation units for this. Size of each allocation unit is 4 MB. So it means that size of my 14. I'm giving it as 16 MB. Okay, now the table space got created. Let me see the name of the file. So as this is in a different disk group, so every disk group has its own free space table. So we'll get the file name is a different one, right? 256. We just have the same file number given for the previous table space, but as these two are in two different disk groups, so we'll get the file number starting from the 256. Now okay, so now I want to view the data for the data files which belongs to this. So this is a high redundancy disk group having the disk from 13 to 15. Okay, I'm just opening this disk 13, and the block number 2 is the allocation table for this. When we are looking at this, so here we can see that this is the allocation table block with string size as 448 and AU number. This is from AU 0, allocation unit 0 to allocation unit 445. The first 445, 448 allocation units are addressed in this allocation table block. Now let's try to find the similar thing, the 256. We can see here all the 6 extents. This is the latest 256 file with extra numbers 3, 8, 11, 12. These are the extra numbers. Now let's try. Size of my disk is 3 GB, which is nothing but 1024 into 3. The value is 3072. Now if I divide this into 448, so 6.8 blocks I'll be getting. But what is the size of my allocation unit? It is 4 MB. First, let me show you the stride size. In fact, is the size of the stride, right? So, as I said in my previous video, if I have a 4 MB of allocation unit size, and it can have 4,54,272 entries, it means that 4,54,272 allocation unit information I can hold it in the allocation table, because when I'm having a allocation unit of 4 MB and each metadata block is of 4 KB, then in that case I'll be having 1000 plus allocation table blocks. So each allocation table block is holding 448 entries, then 1000 into 448, which is nothing but 4,54,272 allocation units that can be addressed in this allocation table with a 4 MB of size. So with this, we were able to find out the extent number and the file number for which a particular allocation unit has been assigned by using the kfet utility and we can also compare it from the $X views. Thanks for watching this video.